Alright, we're on to chapter 10, and today we're starting with 10.1, which is sums and differences of functions. Now, sum and difference means adding and subtracting. So, when you see the sum of a function, that means that h of x equals f of x plus g of x. So when you see these different letters out in front of you guys, those are just different names of functions, just to say that this f of x function is a different function than this g of x function. Just like you guys all have names, we're just giving these names to these functions. So again, the sum is when you add two functions together, or you can write it as f plus g with the x on the outside. So you can write this in both ways. The difference is when we're subtracting two functions, and again, you can also write that as f subtract g of x. So again, we say this is f plus g of x, and f subtract g of x. So here we have example 1. It says if f of x is 2x plus 3 and g of x is x squared minus 1, we're going to determine the function h of x equals f plus g of x. So we're going to say that h of x equals f of x plus g of x. So again, that's what we're asking to do is we're adding the function f to the function g. The function f is actually 2x plus 3. And the function g is x squared minus 1. So all I'm doing is adding these two functions together. Now when you add functions, what can you add?
Like terms.
Like terms, exactly. We can only add like terms. So when I look at this, okay, the x squared has nothing I can add to it. The 2x has nothing I can add to it. But I put the 3 and the 1 together, and I get a plus 2. So this means that h of x equals x squared plus 2x plus 2.
But we can factor.
Now on your test, I want you to make sure you actually write h of x in the front, like that's our new function name. So make sure you write it like this. We don't need to factor this. No, we just are adding it together and combining like terms. So this can be your final answer. So next year we're going to sketch all three of these functions on the same coordinate system using a table of values. So here I've got x is negative 2. So if I plug negative 2 in for x in my first function, we're going to get negative 2 times 2 is negative 4, plus 3 is going to give me a negative 1. And I'm going to continue that process with all of the f of x function by plugging in negative 1, 0, 1, and 2. So once we have our table of values for f, we're going to graph this. So at negative 2, my graph was at negative 1. At negative 1, it was at positive 1, and we're going to continue on. Note that this function should be linear because if you look at the equation, it has a degree of 1, so this should make a straight line. Now we're going to go ahead and graph g of x using the same method. You should notice that g of x is a parabola shape because it has the squared power. So far we have a line for f of x and a parabola for g of x. Now we're going to find h of x. So now since h of x is our f of x plus our g of x, that means I can add the y values from f of x to g of x, and I'll get my new h of x values. So minus 1 plus 3 gives me 2, 1 and 0 gives me 1, 3 and minus 1 gives me 2, 5 and 0 is 5, and 7 and 3 is 10. Now the other option is we could have plugged all our x's in here to the equation that we found earlier, but I think that would take longer. So now I have a new set of y values. What shape should this function be? A parabola as well. Right, because if I look up here, I have a squared term in my equation. So at minus 2, my h of x graph is at 2. At minus 1, it's at 1. At 0, it's at 2. At 1, it's at 5. And at 2, it's at 10. And then you can assume, since it is a parabola shape, that it'll continue on the other side. So we get h of x looks something like that. Alright, now we need to find domain and range. So, looking at domain for these, the domain would be an element of real for h, because it is a parabola, and the range is going to be greater than or equal to 1. Now I want to just point this out right here. This says that the domain is whatever is common between the domains of the individual functions. So if you look, we said our new domain for h of x is an element of reals. But if you look at our other two functions, so the line, the domain is an element of reals, and the green parabola, the domain is an element of reals. So since both of those domains are an element of reals, your new domain is also going to be an element of the reals. So again, your new domain, when you add two functions together, is whatever is common between your original domains. So if we're looking for the value of f of x when x is -5, we write that as f of -5. That's how we write this properly. Because that means the -5 is going into the x spot. So we'd say that this is then 2 times -5 plus 3. So 2 times -5 is 10 plus 3. So f of -5, we should have got -7. G, same thing. I'm going to plug in -5 in for x in the g equation. So we get -5 squared minus 1, which is 25 minus 1, so 24. Now h, I know I could plug it into my original equation, or what's my other option to find h? Add these two together, right? Because h is f plus g. So I can just take 24 and add the -7, which is really like subtracting 7, which means h at -5 would equal 17. Alright, so example 2, we have f of x is root of x minus 1 and g of x is x minus 2. We're finding a function of that is h of x, which equals f minus g of x. So this time we are subtracting. So let's start by finding our equation. So h of x is f, which is x minus 1, subtract g, which is x minus 2. Now, remember that you can only combine like terms, but with radicals, you can't combine anything under the radical, because the radical part is considered its own like term. So the only thing I can do to simplify this one is distribute that negative into the bracket, that's subtracting. So we get minus x plus 2. So that's it. So h of x is going to equal that. So f of x is actually undefined for the first 3 points. Then when you plug 1 in, we're going to get 1 minus 1, which you can square root, and you get 0. So my first point is actually at 1 and 0. If you continue, your next point would be at 2 and 1, 5 and 2, 10 and 3. So this would be your graph of f of x. So notice that f of x has a domain of greater than or equal to 1. So be careful, the domain is only greater than or equal to 1. Now let's take a look at g of x. Now g of x is linear. So at minus 2 it's at minus 4, at minus 1 it's at minus 3, at 0 it's at